For over 50 years, the silvery disk in our night sky has remained uninhabited. The last footprints of human boots in the lunar dust, left in December 1972, have long since become part of history, frozen in a vacuum. We have grown accustomed to perceiving the moon as a beautiful but dead backdrop to which we have supposedly already found all the keys. But what if this long period of silence was merely the lull before the greatest leap in our history? Today, humanity stands on the threshold of a new era. This is not just another rocket launch. This is the Artemis II mission. This is the moment when four brave explorers will once again break the bonds of Earth gravity to look at the far side of our satellite with their own eyes. Why are we returning right now? What secret does the south pole of the moon hide that has forced the world's leading space powers to start a new race? And most importantly, are we ready for the risks that await the crew beyond the protective magnetic field of Earth? In this film, we will trace the path from the blueprints in the offices of the National Aeronautics and Space Administration to the fiery pillar of smoke at Launch Pad 39B. We will disassemble every screw of the most powerful rocket in the world, look into the eyes of the people who will become the first messengers of Earth in deep space in over half a century, and understand why Artemis II is not the end of the journey, but only the foundation for our future on Mars. Get ready because the journey of 400,000 kilometers begins right now. Before we start, write which city you are from so that we know how far our stories travel. To comprehend the scale of what we are trying to achieve today, we must take a deep excursion into the past, to the origins of our desire to go beyond Earth. On December 11, 1972, the Apollo 17 mission marked the end of the first chapter of the lunar epic. Commander Eugene Cernan, standing on the surface in the Taurus Littrow Valley, said that we would return with peace and hope for all mankind. However, for the next 5 decades, those words seemed like only a beautiful promise lost in political labyrinths and economic crises. Why did this huge gap in time occur? In the scientific community and among space historians, there is a clear understanding. The Apollo program was a child of the Cold War. It was not so much a scientific project as a demonstration of technological superiority over the Soviet Union. At its peak in the mid-60s, the program consumed almost 4% of the entire federal budget of the United States of America. Once the political goal was achieved and the first 6 landings proved that humans could work on the moon, the government and the public began to lose interest. The costs of the Vietnam War and social reforms became priorities, and 3 planned missions, 18, 19, and 20, were canceled, even though the rockets and ships for them had already been partially built. After Apollo, the strategy of the National Aeronautics and Space Administration changed dramatically. Humanity focused on exploring the so-called low Earth orbit, the space at an altitude of 200 to 400 kilometers. This was the era of the space shuttles, which began in 1981. The shuttles became space trucks that allowed us to build the International Space Station, a grandiose project involving 15 countries. On board this station, we spent over 20 years learning how to live in space, studying the degradation of muscles and bones in weightlessness, testing closed-loop water and air purification systems, and observing the impact of long-term isolation on the psyche. As experts note in the journal Science, without the experience of the International Space Station, a mission to the moon today would be impossible. We simply would not know how to support the life of a crew for 10 days in deep space. However, the moon never disappeared from the plans of scientists. In 2009, using the Lunar Crater Observation and Sensing Satellite Probe, a controlled collision with the south pole of the moon was conducted. The results of the analysis of the ejected dust shocked the scientific world. A significant amount of water ice was detected in the Cabeus crater. This discovery, published in the journal Nature, overturned our understanding of the satellite. It turned out that the moon is not only an object for photography, but also a strategic bridgehead. Water is the gold of space. From it, one can obtain oxygen for breathing and hydrogen for rocket engines. This means that we can refuel ships directly on the moon without lifting huge fuel reserves from the heavy Earth. It was this discovery that became the spark for the creation of the Artemis program. The name symbolizes the feminine principle and equality, as Artemis aims to send the first woman and the first person of color to the moon. The political foundation was laid in 2017 with the signing of Space Policy Directive Number 1. The new flight architecture differs significantly from Apollo. Now we use international cooperation. For example, the European Space Agency is responsible for the service module of the Orion spacecraft, without which the flight would be impossible. This is no longer a race for survival but sustainable development. In November 2022, the first critical stage took place, the Artemis I mission. It was an uncrewed test for the Space Launch System. The rocket worked perfectly, and the Orion spacecraft spent 25 days in space, orbiting the Moon in a distant retrograde orbit. The main achievement was testing the heat shield. It withstood temperatures of 2,760 degrees Celsius during atmospheric entry at a speed of 40,000 kilometers per hour. Data from mannequins equipped with thousands of radiation sensors confirmed that radiation levels inside the ship remain within acceptable limits for humans. Therefore, the Artemis II mission is a logical and extremely complex continuation of this path. We are not just repeating the achievements of 50 years ago. We are using 21st century digital technologies, artificial intelligence for navigation, and new composite materials. This is a bridge between a glorious past and a future where the Moon will become our 8th continent. It is a story of how humanity, realizing its mistakes and the limited resources on its home planet, again turns its gaze to the stars to find answers to questions about our origins and future. To send a crew of 4 to the Moon, humanity needed a machine that, in its complexity and power, surpasses any vehicle ever created by our civilization. We are talking about the Space Launch System, known as SLS. This is not just a rocket. It is the culmination of decades of scientific research that combined proven technologies from the space shuttle era with innovative solutions of the 21st century. The height of this construction in the Block 1 configuration, which will be used for the Artemis II mission, is 98 meters. Imagine a 30-story building filled with thousands of tons of cryogenic fuel and capable of developing speeds tens of times higher than the speed of sound. The foundation of this rocket is the core stage, a giant orange cylinder 8.4 meters in diameter. Its color is due to a special thermal insulation foam that protects the internal tanks from overheating and overcooling. Inside this stage are 2 huge reservoirs. The first is filled with 730,000 liters of liquid oxygen, which is stored at a temperature of minus 183 degrees Celsius. The second reservoir contains over 2 million liters of liquid hydrogen at a temperature of minus 252 degrees Celsius. These components are extremely volatile and dangerous, but it is their reaction that provides the incredible energy needed to exit into deep space. At the base of this stage are 4 RS-25 engines. These are legendary engines that previously lifted space shuttles into the sky. But for the Artemis program, they underwent deep modernization. Specialists from the Aerojet Rocketdyne Company installed new engine controllers that operate faster than any home computer, constantly monitoring pressure, temperature, and fuel flow rate. Each of these engines creates a thrust of 228,000 kilograms. Together, they work for 8 minutes, burning fuel at a rate that could empty an Olympic swimming pool in seconds. However, even this power is not enough to lift 2,600,000 kilograms of total weight from the launch pad. Here, 2 solid rocket boosters come into play. They are the largest and most powerful boosters ever created for human flight. Each booster is 54 meters high and consists of 5 segments filled with solid fuel that resembles an eraser in consistency. During launch, these boosters provide over 75% of all thrust. The total power of the system at launch is 8.8 million pounds of thrust. This is 15% more than the legendary Saturn V rocket. This is the physical embodiment of the power of the human mind over gravity. At the top of this fiery column is the brain and home for the astronauts, the Orion spacecraft. It consists of 2 main parts, the crew module and the service module. The command module, where the crew will be located, is shaped like a truncated cone. Its internal volume is 50% larger than that of the Apollo capsule, allowing the 4 astronauts not just to sit, but also to perform physical exercises necessary to maintain health and weightlessness. The module structure is made of an aluminum-lithium alloy, combining incredible strength with low weight. Located beneath the crew module is the European service module, Created at the request of the European Space Agency by the Airbus company. This is the heart of Orion's life support. It carries 4 solar panels that unfold in the shape of wings after reaching orbit and provide the ship with electricity. The module also contains 33 engines of various power for maneuvering and orientation in space. Its tanks store drinking water, oxygen, and nitrogen to create a breathing atmosphere identical to that of Earth. This is critically important because past missions used pure oxygen at low pressure, which was extremely flammable. The launch abort system is another masterpiece of engineering that deserves detailed explanation. It is a small rocket mounted directly above the crew capsule. It remains on standby from the moment the astronauts board the ship until it reaches a stable orbit. In the event of any critical situation with the main rocket, the abort system engines fire in 40 milliseconds. They generate a thrust of 400,000 pounds, allowing the capsule to be instantly pulled away from the danger zone with an acceleration of up to 15 units. This is a guarantee that the lives of the crew are a higher priority than the preservation of expensive equipment. For the journey from Earth orbit to the Moon, another component is used, the interim cryogenic propulsion stage. It is equipped with one RL-10 engine that runs on liquid hydrogen and oxygen. This engine is known for its incredible reliability and ability to start in deep vacuum after long periods in the cold of space. It will provide Orion with that final push to accelerate to 11 kilometers per second and escape the gravitational well of Earth. Every element of this system, from a tiny temperature sensor to the huge fuel tanks, is the result of the work of over 3,800 companies in all 50 states of America and many European countries. This is not just a technical description. It is a story of how millions of hours of labor by engineers, mathematicians, and physicists were embodied in metal and fire to make the return of humans to the Moon possible. We have created a tool capable of withstanding the extreme conditions of open space, where temperatures fluctuate from plus 150 degrees in the sun to minus 150 in the shade. Behind every titanium bolt, every complex line of code, and every megawatt of energy bursting from the rocket nozzle stands the most important element, the human being. The Artemis II mission is not just a triumph of automation, it is the return of human presence to deep space. For this historical flight, 4 individuals were selected whose biographies are the embodiment of professionalism, endurance, and dedication to science. This is the crew that carries the weight of the hopes of 8 billion inhabitants of Earth on their shoulders. Reed Wiseman has been appointed commander of the mission. His path to the captain's bridge of Orion lay through thousands of hours of flights on carrier-based fighters of the United States Navy. Reed is the embodiment of calm and analytical thinking. In 2014, he already spent 165 days aboard the International Space Station, where he proved to be a masterful operator of complex systems and a person capable of keeping a cool head in critical situations. His role in Artemis II involves overall command of the ship in coordination with the Johnson Space Center in Houston. As commander, he is responsible for the safety of the crew and the successful execution of every stage of the flight plan, from separation from the rocket's second stage to the final splashdown. Victor Glover was chosen as the pilot of the ship. Victor is a captain in the Navy who has experience flying over 40 different types of aircraft. His participation in the mission is deeply symbolic and historical, as he will become the first person of color to go beyond low Earth orbit and see the far side of the Moon. In 2020, Victor was the pilot of the first regular operational mission of the SpaceX Crew Dragon ship. His technical literacy and skills in piloting modern digital systems make him a key figure in managing Orion. It is Victor who will directly interact with the control panels, controlling thrust vectors and ship orientation during complex maneuvers near the lunar surface. Christina Koch became the first mission specialist. Her resume impresses even seasoned space veterans. Christina is an electrical engineer who spent 328 days in space, setting a record for the longest continuous stay in orbit by a woman. She participated in 6 spacewalks, totaling over 42 hours. Her scientific background includes work at the Amundsen Scott and Palmer Antarctic stations, where she tempered her character in conditions of extreme isolation. In the Artemis II mission, Christina will be responsible for the operation of scientific instruments and life support systems. She will become the first woman in history to overcome the 400,000-kilometer mark from Earth, forever breaking the glass ceiling of space exploration. The fourth member of the crew and the second mission specialist is Jeremy Hansen, a representative of the Canadian Space Agency. His appointment emphasizes the international status of the Artemis program. Jeremy is a colonel in the Royal Canadian Air Force and an experienced CF-18 fighter pilot. For many years, he worked in the Operations Planning Department, preparing other astronauts for flights. For Canada, this is a moment of national pride, as Jeremy will become the first citizen of this country to leave low Earth orbit. His presence in the crew is the result of close cooperation between countries and Canada's contribution to the creation of robotic systems for the future Lunar Gateway Station. The preparation of this crew is an unprecedentedly intense process lasting over 2 years. It includes not only the technical study of every button in the Orion cockpit, but also deep psychological and physical adaptation. The astronauts spend hundreds of hours in the Neutral Buoyancy Laboratory, a giant pool in Houston where they learn to operate in conditions simulating weightlessness. Although a spacewalk is not planned for this mission, they must be ready for any emergency situations, including repair work outside the ship. Geological training is an important stage. Even though the crew will not land on the surface, they must be qualified observers. Under the guidance of leading planetary scientists, the astronauts study the morphology of lunar craters, features of the relief, and lighting. They train to identify interesting geological formations at a speed of thousands of meters per second, so that during the lunar flyby, they can record data that will help select a landing site for the future Artemis II mission. Physical preparation includes training on centrifuges to adapt to gravity loads that will reach 7 to 8 units during launch and return. Special attention is paid to the water survival system. The astronauts train to evacuate from an Orion capsule mock-up in the middle of the open sea, as they may wait for Navy rescue ships for several hours after splashdown in the Pacific Ocean. The psychological cohesion of the crew is perhaps the most important factor for success. 10 days in a confined space with a volume of 9 cubic meters requires perfect interaction. They learn to understand each other's facial expressions and gestures, share limited space and resources, and maintain high productivity in conditions of constant stress and lack of normal sleep. This crew is not just a team of professionals. It is a family ready to trust each other with their lives in the harshest environment known to man. These 4 heroes are symbols of a new era. They represent different nations, different genders, and different professional paths, but they are united by one common goal: to expand the boundaries of human capabilities. When Artemis II lifts off from the launch pad, these people will become our eyes and ears in the darkness of space, reminding us that we are a species of explorers for whom the horizon is just another challenge. When the giant clouds of steam and flame settle over the Kennedy Space Center, and the roar of the 4 RS-25 engines dissolves into the upper layers of the atmosphere, the most complex navigational ballad in the history of modern astronautics will begin for the crew of Artemis II. Unlike the missions of the last century, this flight is not a straightforward dash to another celestial body. It is an exquisite multi-stage operation where every maneuver is the result of billions of calculations performed by the supercomputers of the National Aeronautics and Space Administration. The first 8.5 minutes of flight are just a prelude. After the main stage of the rocket completes its work and detaches, Orion, together with the interim cryogenic propulsion stage, will be in a primary parking orbit around Earth. However, the real magic begins 45 minutes after launch. Instead of immediately setting a course for the moon, the upper stage engine will fire for a maneuver that will raise the apogee, the highest point of the orbit, to an altitude of approximately 2,900 kilometers. This is only the first step. The most unique feature of the Artemis II mission, which distinguishes it from the legendary Apollo 8, is staying in a high elliptical Earth orbit for the first 24 hours. After the second engine firing, Orion will enter an orbit with a perigee of 185 kilometers and an apogee of an incredible 74,000 kilometers. Why was such a complex trajectory chosen? The answer lies in safety. During these 24 hours, the crew, led by Reed Wiseman, will conduct a thorough diagnosis of all life support systems. Engineers want to be 100% sure that the air regeneration, thermal regulation, and communication systems are working perfectly before giving the command to go into deep space. If the slightest anomaly is detected at this stage, the high elliptical orbit will allow the ship to return to the Earth's atmosphere in just a few hours. During this period, one of the most important technical demonstrations will take place: proximity operations and orientation. The crew will detach Orion from the empty upper stage of the rocket, fly away to a certain distance, and then, using manual control, approach it again. Victor Glover will use the ship's cameras and sensors to keep Orion in a fixed position relative to the stage. This is critically important training for future Artemis III and Artemis IV missions, where ships will have to dock with lunar landing modules and the Gateway Station. Only after the Mission Control Center receives confirmation that Orion is a fully functional space home will the moment of translunar injection arrive. This is the final impulse that will accelerate the ship to a speed of over 11 kilometers per second, the speed necessary to leave Earth's orbit forever. When the engine goes silent, the crew will officially become travelers in deep space. The journey to the moon, 380,000 kilometers long, will take approximately 4 days. During this time, Orion will move along what is called a free return trajectory. This is true mathematical insurance. Its essence is that the ship is directed not directly at the center of the moon, but at a point ahead of it in the direction of its movement. If the engines of the service module created by the European Space Agency fail for some reason near the moon, the gravity of our satellite will itself catch the ship, turn it around, and, thanks to the gravitational slingshot effect, send it back to Earth. This is an ideal passive safety system. The laws of physics of Isaac Newton and Albert Einstein guarantee the return of the astronauts home even with a complete failure of the propulsion system. On the 4th day of the flight, the climax will occur. Orion will approach the moon and fly at a distance of approximately 10,300 kilometers from its surface. This is a moment of incredible visual and scientific weight. The crew will fly over the far side of the moon, territory that is never visible from Earth due to tidal locking. Unlike the familiar plains and seas of the near side, the far side is a total chaos of craters formed over billions of years under asteroid strikes. Christina Koch and Jeremy Hansen will document the landscape using ultra-high-resolution cameras. They will see the Schrödinger crater in the South Pole Aitken Basin, one of the largest impact features in the entire solar system. While passing behind the moon, a period of radio silence will occur. For 40 minutes, the mass of the satellite will block all signals from Earth. In this absolute silence, where the only sound will be the faint hum of the life support system fans, 4 people will be the most isolated beings in the universe. At this very moment, they will see the Earthrise over the lunar horizon, a sight that forever changes the consciousness of any astronaut, demonstrating the fragility and unity of our planet in an ocean of void. After the lunar flyby, the free return trajectory will begin to direct Orion back home. The return journey will last about 4 more days. During this period, the intensity of work will not decrease. The crew will conduct regular course corrections using small orientation engines to precisely hit the narrow corridor of entry into Earth's atmosphere. A mistake of just 1 degree can lead to either burning up in the dense layers of air or ricocheting off the atmosphere back into open space without the possibility of return. Every kilometer of this journey is a test of theories and practice. The Artemis II mission does not aim for a speed record, it aims to create a reliable route. We are again paving a path in the darkness so that subsequent missions can move along it confidently, carrying equipment for the first lunar settlements. This is a journey where mathematics becomes the art of rescue and gravity becomes a reliable ally. When the Orion spacecraft leaves low Earth orbit, it goes beyond the magnetic shield of our planet. For the crew of Artemis II, this means meeting the most insidious enemy in deep space: ionizing radiation. This is an invisible threat that cannot be felt, seen, or heard, but it is capable of destroying biological structures at the molecular level, breaking DNA chains in the astronaut cells. During the 10 days of the mission, the crew will be exposed to 2 main types of radiation: galactic cosmic rays arriving from distant supernova explosions and solar particles ejected during sudden flares on our star. The first serious test is the passage through the Van Allen radiation belts. These are 2 huge toroid-shaped zones surrounding Earth that hold high-energy charged particles captured by the planet's magnetic field. The inner belt consists mainly of extremely high-energy protons, and the outer belt consists of electrons. Although Orion will fly through them at enormous speed, protecting the crew is a critical engineering task. For this, specialists from the National Aeronautics and Space Administration have developed a unique radiation shelter strategy. In the event of a solar storm, astronauts are to move to the central part of the crew module, surrounding themselves with bags of water, food packages, and other equipment. The hydrogen contained in the water and plastic packaging is one of the best natural barriers for blocking heavy ions. In addition, a system of sensors is installed on board that maps the radiation situation inside the capsule in real time, allowing the crew to choose the safest place. The second huge challenge is maintaining communication and navigation in absolute void. Imagine you are in an ocean without any landmarks, where there is no familiar global positioning system to which we are accustomed on Earth. How do you understand exactly where the ship is, rushing at a speed of 11 kilometers per second? For this, Orion uses the Deep Space Network. This is a system of giant antennas up to 70 meters in diameter, located at 3 strategic points of the planet: Goldstone in the state of California, Madrid in Spain, and Canberra in Australia. Thanks to this arrangement, no matter how the Earth turns, at least one antenna always sees the ship. However, even radio waves moving at the speed of light need more than 1 second to cover the distance to the moon and back, creating a noticeable delay in conversations. However, the Artemis II mission also tests innovative autonomous navigation. The ship is equipped with optical navigation cameras that photograph Earth and the moon against the backdrop of distant stars. A special algorithm compares these images with a huge database of the starry sky and calculates the ship's position with an accuracy of several meters without the help of ground stations. This guarantees that the crew will be able to find their way home even in the event of a total loss of communication with Houston. Special attention deserves the revolution in data transmission, the O2O optical communication system. Instead of traditional radio waves, data will be transmitted using infrared laser beams. This will allow for the transmission of high-definition video in 4K format from the far side of the moon practically in real time. This is like changing an old copper wire for modern fiber optics, allowing humanity to see the moon in such detail for the first time that was previously available only in science fiction films. One should not forget about the physiological impact of deep space. Although 10 days is a relatively short period compared to an expedition to Mars, microgravity begins to fundamentally change the human body in the very first hours. Fluid in the body is redistributed from the lower limbs to the upper torso and head, causing swelling and a feeling of constant nasal congestion. Astronauts call this effect puffy face. But a more serious problem is the impact on the eyes. Due to increased intracranial pressure, the shape of the eyeball can change, leading to vision deterioration. In addition, the vestibular apparatus, deprived of the usual up-down orientation, begins to fail, accompanied by space motion sickness. The crew must perform daily physical exercises using special expanders to prevent muscle atrophy and the leaching of calcium from the bones. All these data, from radiation doses to changes in the blood composition of astronauts, will become the foundation for planning future missions, where people will have to spend years in space. The scientific challenges of the Artemis II mission show us how hostile the environment is beyond our cradle. However, it is the solution of these complex tasks that drives earthly progress forward, creating new methods for treating diseases, more efficient communication systems, and materials that will later find application in our daily lives. Every minute of the crew's struggle with invisible dangers is a step toward the day when space will become for us not a hostile environment, but a new home. The successful completion of the Artemis II mission will be the very cornerstone on which humanity will build the foundation of its first extraterrestrial civilization. If the second mission is a grandiose dress rehearsal, then Artemis III, planned for 2026 or 2027, will be the main event of the 21st century, the first landing of humans on the surface of another celestial body since the end of the Apollo program. But this time, the strategy is fundamentally different. We will not limit ourselves to equatorial regions where the landscape is relatively flat and predictable. Our goal is the south pole of the moon. This is a place of extreme physical contrast. Thanks to the small tilt of the moon's axis of rotation, only 1.5 degrees, certain mountain peaks at the poles are bathed in eternal sunlight, making them ideal places for solar power plants. At the same time, the floors of deep craters have been in absolute darkness for billions of years. These zones are called permanently shadowed regions. The temperature there drops below minus 180 degrees Celsius, turning them into natural cryogenic traps. It is there that we discovered deposits of water ice mixed with regolith. This is the most valuable resource in the solar system. Water is not just a source of drinking for astronauts. Through electrolysis, using solar energy, we can split it into oxygen for breathing and hydrogen for rocket fuel. This means that the moon will stop being a desert where we must bring every liter of resources from Earth. It will turn into the first space refueling station. A key element of this new architecture is the Gateway Station, the first multi-module space laboratory to orbit the moon. Unlike the International Space Station, which flies in low Earth orbit, Gateway will be located in a unique near-rectilinear halo orbit. This is an extremely elongated trajectory that allows the station to constantly be in direct line of sight of Earth for uninterrupted high-speed communication and, at the same time, pass very close to the lunar pole for the convenience of landings. This project is a true triumph of global diplomacy and science. The European Space Agency is developing residential and refueling modules such as iHab and Esprit. The Japan Aerospace Exploration Agency provides critical life support systems and batteries. The Canadian Space Agency is creating a new version of the intelligent manipulator, Canadarm3, which will independently service the station from the outside using artificial intelligence. The Artemis program has also opened doors for unprecedented cooperation with the private sector, fundamentally changing the economics of space. The SpaceX company, under the leadership of Elon Musk, is developing Starship HLS, a giant landing module that will dock with Orion or the Gateway Station and deliver the crew to the surface. This is no longer the cramped cabin of Apollo, but a full-fledged multi-story ship capable of carrying tens of tons of cargo, scientific equipment, and even the first elements of lunar bases. Simultaneously, the Axiom Space Company is developing next-generation spacesuits that provide much greater mobility and protection from sharp lunar dust. In them, astronauts will be able to easily perform complex geological work, bend over, and collect ice samples from the bottom of dark craters. But the moon is only the beginning of our great journey. In the official strategic documents of the National Aeronautics and Space Administration, the paradigm is clearly fixed: Moon to Mars. On our satellite, we will learn to extract resources in conditions of different gravity, which is only 1/6 of Earth's. We will test new types of low-power nuclear reactors for uninterrupted energy supply during long lunar nights that last 14 Earth days. We will check how the human body and psyche react to long-term stays beyond the protective belts of Earth. A journey to Mars is an expedition lasting 2 or 3 years. At such a distance, help from Earth will be impossible, and the communication signal delay will reach 20 minutes. We cannot afford a single mistake in the regeneration or thermal regulation systems on the way to the Red Planet. Therefore, every day spent by astronauts on the lunar station or in the Artemis camp is actually a large-scale rehearsal for survival on Mars. We are learning to grow plants in lunar soil, regolith, previously cleaned of toxic compounds, and to create building materials using 3D printing using local minerals. In the future, in 20 or 30 years, we see the moon not as a dead object for observation, but as an active scientific, industrial, and logistical hub. Giant radio telescopes will be located here on the far side, which, being protected by the mass of the moon from the radio noise of Earth, will be able to look into the dark ages of the universe, the era before the emergence of the first stars. Automated factories will operate here, providing fuel for interplanetary ships. And all this will become a reality only because 4 people in the Artemis II mission will take their first incredibly responsible step into the deep blackness of space. We are again becoming a nomadic species, expanding our range beyond our home planet, carrying with us knowledge, culture, and hope that intelligent life can take root among the stars. After 10 days of an incredible journey, having covered over 1 million kilometers in a merciless vacuum, the crew of Artemis II approaches the final, most intense stage of their mission. The moon, which only recently seemed like an immense world under the ship's wing, again turns into a silvery ball behind them, and the majestic blue sphere of Earth rapidly grows before the Orion windows. However, returning home is not just a flight in a straight line. It is the most dangerous test for the ship's construction and the astronauts' endurance. The first critical moment is the separation of the command and service modules. Approximately 40 minutes before atmospheric entry, pyrotechnic bolts sever the connection between the crew capsule and the European service module. The service module, which faithfully served the crew throughout the flight, providing them with energy and air, moves aside and will later completely burn up in the upper layers of the atmosphere, having performed its last function, protecting the capsule until the very last moment. From this time, the four astronauts remain in a small cone that must hit an extremely narrow entry corridor. A mistake in the entry angle of just a few tenths of a degree can lead to disaster. If the angle is too steep, the ship will experience excessive gravity loads and burn up. If it is too shallow, it will ricochet off the atmosphere like a flat stone off water and fly back into space without a chance of return. For the Artemis II mission, engineers from the National Aeronautics and Space Administration have developed a unique maneuver called skip entry. The ship first dips into the upper layers of the atmosphere to bleed off some speed, then, using its aerodynamic shape, rises higher again as if jumping on a cushion of air, and only after that performs the final plunge. This significantly reduces thermal loads on the shield and, most importantly, reduces gravity loads for the crew, making the landing smoother and safer. The speed of Orion during collision with the air is approximately 40,000 kilometers per hour. This is 32 times faster than the speed of sound. At such speed, air molecules do not have time to move out of the way and compress in front of the ship, turning into incandescent plasma. The temperature on the surface of the heat shield rises to 2,760 degrees Celsius. This is almost half the temperature of the sun's surface. The Orion heat shield, made of a material called avcoat, works on the principle of ablation. It gradually chars and burns away layer by layer, carrying away colossal thermal energy and maintaining a comfortable temperature of 25 degrees Celsius inside the cabin. At this moment, an ionization cocoon forms around the ship, completely blocking all radio signals. For approximately 8 minutes, which Mission Control calls minutes of terror, the crew is in total radio silence. The world stands still, waiting for a signal from the Pacific region. The astronauts inside feel a mounting gravity load that is 6 to 7 times Earth's gravity. This is a moment of maximum physical and psychological tension. At an altitude of approximately 7,600 meters, when the speed drops to subsonic, the automation deploys the parachute system. First, 2 drogue parachutes open to stabilize the capsule. Then at an altitude of about 3,000 meters, 3 white and orange main canopies fire. Each has an area comparable to a basketball court. Under these giant sails, Orion gently descends into the waters of the Pacific Ocean off the coast of California. A United States Navy ship is already waiting for them in the splashdown zone. Specially trained teams of divers and engineers ensure the safety of the crew and the evacuation of the capsule. When the Orion hatch opens and Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen breathe in the salty sea air of Earth, the mission officially ends in success. They return not just as pilots or scientists, but as messengers of a new era. The true legacy of Artemis II lies not only in technical achievements, but in the change of our consciousness. This flight returns to us a sense of wonder and endless possibilities. We have proven that we are capable of overcoming differences on Earth for the sake of a great goal among the stars. Just as the Apollo missions once inspired a whole generation of engineers and inventors who created the computer revolution, so will Artemis inspire today's school children and students to make new discoveries in medicine, ecology, and energy. We are returning to the moon not because of pride, but because of necessity. We do this to better understand our own planet, to find resources for the future, and to ensure the survival of our species in case of global challenges. The Artemis II mission is the first confident step on the way to Mars, to the asteroid belts, and beyond, into the boundless universe. Concluding our journey, we want to remind you of the words often quoted at space agencies. We are a species of explorers. A look at Earth from a distance of 400,000 kilometers reminds us that we have no backup home, and we must protect this blue island of life. Thank you for being with us during this detailed analysis of the Artemis II mission. The future has already arrived, and it begins at Launch Pad 39B. What part of this mission impressed you the most? Do you believe the next step should be Mars, or should we focus on building cities under lunar domes? Your opinion is important to us. Write in the comments, subscribe to the channel so as not to miss the next scientific investigations, and remember, the stars are closer than they seem. Until next time in the boundless space of science.